Okay, Assalamualaikum and a very good morning to all of you. Okay, as I promised in our last class that I will record my lecture, right? So today we will continue with our lesson that we stopped last week. Not last week. We stopped in our last class. Okay, so last class we stopped until this part, right? Which is about the finding rate. Finding rate without a financial calculator. Before this, we have learned about this part, right? We have learned about the time period and also how to find the coupon payment or annual payment. Okay, so the next thing is to continue with interest rate. Okay, so how are you going to find the interest rate? There are two ways. The first way is using the financial calculator. It is not the scientific calculator that we use inside the class. No, it is the financial calculator where you don't have to using the trial and error process. We just key in all the information they are given, then you will find what is the interest rate. But if you don't have the financial calculator, you don't have to worry. You can still find the interest rate using the trial and error. Okay, let's see this slide. Trial and error process. How are you going to do that to find the interest rate or rate, rate of interest? Choose an interest rate and compute the present value of the payment based on this rate. So you're going to find the interest rate that is suitable, that is equals to the present value of inside the question. Okay, and then compare the computed present value. Where is the cursor? I'm going to find the cursor. Oh, it's not there. Okay, compare the computed present value with the actual amount, and then you have to use the interest rate, compute the present value, and compare it with the loan amount it is stated inside the question, the loan amount. So you have to compute the present value and also the loan amount. Is it will be equal to your present value if you use that interest rate that you try to find it. If the computed present value, if let's say you use the interest rate, compute your present value, so it is more than your loan amount, okay, then the interest rate might be too low. Okay, if you use the interest rate and then compute the present value and then it is less than the loan amount, which means that the interest rate that you choose is too high. So you cannot choose the interest rate that is too high and too low. So you have to find the interest rate where the computed present value will be the same like the loan amount, which means that when you use the interest rate to compute the present value will be equal to the loan amount. So it is equal. The loan amount equals to the present value. So which means that the interest rate that you find is fit for the question or problems. Okay, let's see this example. How you going to find the interest rate using the trial and error process. Okay, an insurance company offers to pay you 1,000 per year, so which means that this is the C, annual payment. Okay, for 10 years, the time period is 10 years. If you pay up, if you will pay 6710 upfront, so which means that this is the present value because you pay it upfront before. What rate is implicit in this 10-year annuity? So you just draw the timeline 0 until 10 years. You know that at year 0 you have pay 6710 and then the interest rate, the one that you need to find. Okay, so after you have drawn your timeline, the second step is to write the formula. So present value equals to C, which is your coupon payment, times 1 minus 1 divided by 1 plus I, the power of T or N is just the same. Okay, divide by I, interest rate. So we know that the present value is 6710 and then C or annual payment is 1,000 because you pay 1,000 per year. So 1,000 times with 1 minus 1 divide by 1 plus I, the one that we want to find, and then the time period is 10 years. Okay, divide by I. Alright, so you bring this one 1,000 here, so when it is times with this one, so when you bring it here, it will become divide. Okay, so you divide this one, so you will left with this one, so 6.71. So you go to annuity table. Okay, so annuity table, you need to refer to your book. Okay, if you have your book, so I will share your book. Alright, so I will share your book. Okay, alright, so inside your annuity table, the appendix part, if you have the book inside any edition of your book, okay, you open the appendix part, don't refer to future value of don't refer to table 8.1. Table 8.1 is for time value of money for lump sum. This is for future value of lump sum. Table 8.2 is present value for lump sum. Okay, if you want to refer to the annuity, it is table 8.3 and table 8.4. Table 8.3 is for present value of annuity. Table 8.4 is future value of annuity. So you refer to present value of annuity, because currently we are using the present value of annuity. Okay, all right. So we will use this table. Okay, table 8.3. Table 8.3. Sorry. Okay, so because the time period, because inside here the time period is 10 years, so you're gonna go through the 10 years time period. Okay, so you go to period, you refer to table 8.3 for annuity. You please find the annuity word here. Okay, so you will go through the 10 year. Okay, the 10 year, you will go through the 10 year and then find for interest rate that is referring to 6.71. Okay, if you look at here, 6.71 falls under 8% interest rate. So how are you going to find the interest rate? Okay, so you look at the time period. Okay, period here at table 8.3, which is present value of annuity. Okay, so go to time period 10. You go along the time period 10. Okay, all right. You go along the time period 10. Okay, all right. Go along the time period 10 and then you find for the 6.71 here, because it is here you find the answer is 6.71. So you go to the table, find 6.71, which interest rate falls under 6.71. It is 8%. So you put 8% inside here. Okay, so you know that now the answer of interest rate is 8%. So if you don't believe whether interest rate is 8% or not, you just plug in 8% here. Whether the 8%, if you plug in 8% here, is it will give you 6710 here. Okay, so let's try it. Okay, so 1.08 the power of 10, so you will get 2.16, 2.159. Okay, and then 1 divided by answer, so you will get 0.4632. Okay, and then 1 minus answer, so you will get 0.5368. Divide by 0.08, so you will get 6.71. Okay, times with 1000, so you will get 6710. So it is almost equals to this present value. So that's how you're going to use the trial and error process in order to get your interest rate. Okay, if let's say you still don't understand, then please do let me know. Okay, please WhatsApp me so that I can help you in terms of trial and error process. Okay, don't worry, after this we will do a lot of exercise so that it will be easier for you to understand the trial and error process. Okay, so the next slide is more towards the summary of formula that you will use. You use for this one will be the multiple cash flows. Okay, this one will be the future value of annuity, and then the present value of annuity and also perpetuity. This is the summary of the formula that we use for this slide. Okay, growing annuity. Besides, you learn about the annuity and the present value of annuity, the future value, which is about the ordinary annuity and annuity due. You also need to know about perpetuity. You also need to know about the growing annuity. Okay, how are you going to know whether the question asks you to use this growing annuity or not? When you are given a question, not only state interest rate, it also state the percentage of growth. So you know that you need to use this growing annuity. Okay, so it is what is growing annuity? It is a growing stream of cash flows with a fixed maturity. So you are given a number of periods. In other words, you are given a time period for the question. Besides the growth, besides the interest rate, you are also given the time period. So that is when you know you need to use this formula, growing annuity. So the formula will be present value equals to C, annual coupon, divided by R, your interest rate, or I. It's just the same, minus the growth, times with 1 minus 1 plus G, divided by 1 plus I, the power of T. So all this will be power of time period. Okay, solve inside here, and then only you times with this figure. Okay. Alright, so let's see this example. Growing annuity. A defined benefit retirement plan offers to pay 20,000 per year. So which means that this is the C, per year, for 40 years. So the time period is 40, and increase the annual payment. So which means that there is an increase, there is a growth there by 3%. So we know that the growth is 3%. What is the present value at retirement if the discount rate is 10%? So which means that the R or the I is 10%. So you have all the information, you just write the formula and plug in all the information that we have inside the formula. Okay, so the formula that we will use is the growing annuity, which is this one, this formula. So present value equals to C, which is annual payment, divided by R or I, interest rate, minus with G, the growth, times with 1 minus 1 plus G, which is the growth, divided by 1 plus R, which is interest rate, the power of time period. Okay, so the C is 20,000 per year divided by interest rate or discount rate 10%, okay, minus with G 3%, increase the annual payment by 3%, so the growth is 3%, times with 1 minus 1 plus G, which is 3%, divided by 1 plus 10%, which is the R or I. 10%, the power of 40, because it is 40 years. So you solve inside here first. 1.03 divided by 1.1, so you will get 0.936. Okay, and then don't forget to power of 40. So solve inside the bracket first. Okay, so the power of 40, you will get around 0.0721. Okay, and then 1 minus answer. Okay, and then after you have solved this one, 1 minus this figure. Okay, so you will get 0.9279. Okay, and then don't forget, then only you solve inside here. 20,000. Okay, 20,000 divided by this figure. Okay, 0.10, 0.1 minus 0.03. Alright, so you will get 265.121.57. So that's how you're going to solve this problem using the growing annuity. How are you going to know whether the question is asking you to use growing annuity formula or not? You are given growth, and then you are given also interest rate, and you are given time period. That is when you know you need to use the growing annuity formula. Okay? Alright, besides growing annuity, because we have annuity and perpetuity, we also will have to calculate the growing perpetuity. Okay, so how are you going to know? What is growing perpetuity? It is a growing stream of cash flow that lasts forever. So you are given interest rate, you are given growth, but the growth will, but the cash flow will last forever, or it is grow until you don't know when will it end. It will be infinity, throughout infinity, so you will not know when it will end. Normally this will involve with dividend, the value of your dividend. So when normally the when the question asks you about the dividend, so it is normally involved with the perpetuity. Okay, so the formula will be present value equals to C, your annual payment, divided by your R, your interest rate, minus with your growth. Okay, so let's see this example for growing perpetuity. The expected dividend next year is 1 ringgit and 30 cents, and dividend are expected to grow at 5% forever. See here, forever. So which means that this is perpetuity. Okay, not growing annuity. Yeah, growing annuity, there is a specific time period. But when it is forever or infinity, so which means that this is perpetuity. Okay, and there is a growth, so you know that you need to use the growing perpetuity. Okay, for the next, I will continue in the next video because this video will be only 15 minutes. Okay.